Okay, so we're going to start talking about asymptotes, which are a part of a rational function, especially when you start looking at the graphs and where these occur. We do have a couple of different types of asymptotes, and I'll have those split across different videos. We're going to start with vertical asymptotes. So this, the reason I start with this is because it ties back into our domain. So those spots that we had said were problem spots in our domain are actually now going to be where we have vertical asymptotes appear. Now, the general rule for asymptotes is that the graph will approach them but not touch them. So we saw that with the approaches where the graph kind of went up and down, but there was kind of that invisible barrier line in between that it kind of stayed off of. So we're going to start, like I said, with our verticals, and then we'll tackle on a couple of different types. So we're going to look at the function x over x squared minus 1, and they ask us to find vertical asymptotes, if any, of this particular graph for this particular rational function. So I've got this written down. Now, first off, if we were talking about our domain, we would say x squared minus 1 can't equal 0. That would be kind of where we would start. And then I'm going to add 1. So now I have x squared can't be 1. I'm going to take a square root. So I'm going to have x. Again, we bring in the square root, so we've got to bring in a plus and a minus 1. Now then, my vertical asymptotes are going to get x equals 1 and at x equals negative 1. So whereas the domain, we talked about they could sometimes do this, or we could put 1 comma negative 1. In vertical asymptotes, we're actually going to separate them out. Okay, so we're not allowed to like line them out in order. They need to be separated because these are two different locations. And they do not have the slash through the equal sign like this one did up here. Now, graphically, what we're looking at here, first off, is how they are done. So I'm going to put a couple of marks out here. These are generally denoted with dashed lines, and so since these are vertical, they're going to go up and down. I'm going to have one that goes through 1, and I'm going to have another one that goes through negative 1. So these are now kind of boundary lines where I would expect to see my graph kind of come up here and maybe get close or come down and get close type of idea. And these occur anywhere where we have a domain problem. So like the examples that we saw a couple of times before, there can be more than 1. There may only be 1. If there's not any spots that are off limits, like we saw one of those domain problems, then I don't have any vertical asymptotes at all for something like